In the last videos, we've been looking at the things that make us sick, and now, starting with this video, we're going to look at how does our body fight off these pathogens, and we do it using what's called the immune system. The immune system's main job is to identify and kill pathogens. Highlight, circle star this word, identify, and realize, and I want to summarize this in your own words, this is pretty amazing. My body's made of trillions of cells, right? Trillions of Mr. Boss cells. And my immune system needs to know, hey, that's a Mr. Boss liver cell, leave it alone. That's a Mr. Boss heart cell, leave it alone. That's a Mr. Boss pancreas cell, leave it alone. It also needs to identify the stuff that I breathe in, let's say, like dust and, skin cells from my dog and pollen grains and things that are not pathogens. And while it may, the macrophages and stuff might clean this, this foreign things, and they're not invaders, they're not pathogens. So that's different from when I inhale the flu virus. Now my immune system has to identify that as a pathogen and kill it. So really it's the identifying it part that's really important, and then we'll talk about how does it kill it. The immune system can be thought of as having two different set of pieces. There's non-specific immunity and specific immunity, and this video we'll be looking at the non-specific piece. Non-specific immunity is the general defenses that we have at all pathogens. It's not at a specific pathogen, so it's not like becoming immune, let's say, to the chickenpox virus. That's not what we're talking about here. These are general defenses that work against viruses, bacteria, all sorts of things. Let's talk about the skin first. So your skin is a physical barrier that keeps, bad things, pathogens out of your body. And the way that it's able to do that is that the outer layer of your skin is actually dead skin cells that are constantly falling off. And so it kind of physically guards our body. It's like, think of it like almost like a shell that we're constantly shedding that, if a bad bacteria, let's say, lands on our skin, it's not going to stay there very long because we're shedding 10 million skin cells an hour. In addition, we also have symbiotic bacteria that are covering our skin, and they are living off of the oils that we're producing, and they're digesting, dead skin cells and things like that. But because they're physically there, they help to block any other bacteria from coming in. Like there's just physically not enough room for them, essentially. They kind of crowd out the bad bacteria with these good bacteria. And this actually happens not just on our outside skin, but this actually occurs, realize, this skin barrier is all through my digestive system as well. And we have both layers of protection in that as well. And so here's a picture of what it looks like. This is our skin, and these are all the bacteria on it. Just to give you an idea of how dense we're talking, this is one single hair coming out of one follicle, and you can see all these bacteria. These are good bacteria that are covering our skin and preventing other bacteria from being able to land there and reproduce. Now we also then, of course, have openings in our skin, right? All of our face holes, for example. And so what we have there is we have chemical barriers. In your ears, you have earwax. In your mouth, you have saliva. In your eyes, you have tears. In your nose, in the back of your throat, you have mucus, right? And a lot of these barriers are containing an enzyme called lysozyme, and this enzyme actually acts like an antibiotic that helps to kill and break down bacterial cell walls. When I first learned about this, I thought about something that I do when I get little cuts on the tip of my finger, like a paper cut, and maybe you do this too, is like it's instinctual. I put it in my mouth just to kind of, I don't know, it's something I do instinctually, and I thought, wow, this is probably because there's that lysosome that helps to clean the wound and also act almost like a disinfectant, like an antibiotic. And this is actually common. It's called wound licking, and not just humans do this. It's actually found across the animal kingdom as well. And, dogs will do it. That's why if, a dog gets a surgery, they put it in the cone, right, from up the cone of shame. And it's just because otherwise that dog would lick the cut incessantly. And so it's called wound licking. And if you've ever done it, that's probably what was going on, just instinctual. Mucosal layers also act as a protective barrier in these openings, and they help to block bacteria from actually sticking into the inner epithelial cells. Epithelial cells are the skin cells, so it's kind of like an extra layer of protection. Here's a picture of it working. So imagine this is the inside of your nose. You breathe in something nasty, some bacteria, let's say, and rather than being able to start doing its thing, it gets stuck in the mucus, it gets digested, and then, of course, you have these little hairs, the cilia, that are going to waft it out after it's been destroyed. Nonspecific immune response is the way that our body actually responds if there is an infection. So far we've been looking at kind of nonspecific immune protection as far as the skin protects us against everything. So now we're looking at, if you do have an infection, what are some ways that your body responds that are not specific to, let's say, the chickenpox virus, but just, is done for all things, whether it's a virus or bacteria. The first one we're going to look at is called phagocytosis, and it's done by a macrophage. Macro means large, phage means to eat. A macrophage is a large eater, a big eater. It's a kind of white blood cell that what it does is it does phagocytosis. It takes the bacteria that it's trying to destroy, and it brings it in to the cell. This should look familiar to you. Hopefully you realize this is essentially endocytosis. But we call it phagocytosis because what's going to happen is it's going to be endocytosis. Then we're going to fuse a lysosome. Remember that from the cell unit. Lysosomes are these vesicles that have all kinds of digestive enzymes and acids in them. So it's going to fuse and it's going to digest that bacteria. And that is then, we call that whole process phagocytosis. So that's sort of an endocytosis piece plus a digestion piece. We call that phagocytosis, done by macrophages. Picture showing it. This white blood cell reaching out. It's going to grab onto that bacteria. Here's another picture of it happening. This is phagocytosis. Another example, this macrophage is a big eater doing its thing, eating all these bacteria. And one last picture of it happening as well. So realize these bacteria will be taken in vesicles through endocytosis and then digested in vesicles, and that is phagocytosis. That's a general defense, whether it's gobbling up viral particles or bacteria or little parasitic worms, doesn't really matter. There's a general immune response. The next one's fever, and fever is an interesting one. A lot of times people think that when they get the flu and they get the fever, they think that maybe the flu virus is causing the fever, but that's actually not true. Your body is making the fever happening, not the virus. It hurts the virus to have a fever. Here's the way it works. Your body functions the best, the enzymes in your body work the best at 98.6 degrees Fahrenheit. Well, as a result, the kinds of invaders, the pathogens that like to invade your body, they also work very nicely at 98.6 degrees. That's why they're good at, invading your body. So imagine the flu virus is in your body, it's doing its thing, 98.6. Well, what your body can do to try to slow down the replication of that virus is to increase its temperature. So your body actually jacks the temperature up. That then makes the enzymes of the virus not function as quickly. It's not able to reproduce as quickly, and your immune system has a better chance of getting a handle on the infection. Now, of course, the question is, well, does that hurt my cells too? And the answer is yes, it does. But realize that your cells are much more complicated than a virus. And so your body essentially, it's taking a little bit of a toll on itself, but it's doing this as a way to slow down the infection. And that's why your parents take your temperature to see if you're actually sick or not, because you can't fake a fever, right? You can say you don't feel good, but they take your temperature and you have a 100-degree fever. Well, that tells them, you really are actually fighting something. Doctors do it too, just as a way to rule out infection potentially. It gives you kind of a gauge of how bad the infection is, because if you think about it, let's say you have an infection going on, your body increases the temperature, you're still not winning the fight, your body increases the temperature more, you're still not winning the fight, and next thing you know, you've got like 103, 104-degree fever. That's, it's pretty severe. So it gives your parents an idea, and your doctor an idea of how sick you really are. Now, of course, fever is a double-edged sword, as you probably know, that, you can run a fever that's too high for too long. And so sometimes doctors will actually go out of their way to try to lower your fever. And so it's just kind of this double-edged sword of trying to slow down the replication of the pathogen without causing too much damage to the body. The next one response is called inflammatory response, or inflammation. And what happens here is these macrophages, as they're eating these pathogens, they release a chemical called cytokine, and that will actually increase blood flow to an area, which increases the number of white blood cells that enter into the fight, which is obviously something that we want in that area because we have an infection. That is what inflammatory response is, right? So it's increased blood flow to the area where you have an infection, and that makes the blood vessels even more permeable, allowing the white blood cells to enter and get into the fight. This is why when you get a cut, you'll get swelling and redness around it. The redness is because you get more blood flow to that area, and the swelling is because you're getting that fluid buildup. This is why when you get a cut, you get the redness around it, right? We've all seen stuff like that before, and so that's because you have that inflammatory response occurring. Realize that before you had the cut there, the skin had bacteria covering it, and once you get the cut, the bacteria enter into the wound, and those bacteria have to be removed, and so you get that, just like in the picture shows, on your study guide, you get increased blood flow, more white blood cells into the fight to get the infection taken care of. Same thing happens when you get pimples. What happens when you get this inflammatory response is, as the battle is kind of waging and there's dead bacteria building up, is your body builds this stuff called pus. And pus is sort of a conglomeration of chemicals that are being used as part of the inflammatory response, plus the dead debris from the bacteria and the viruses that are being destroyed there. If it's a really bad infection, sometimes the body will even warehouse these things in big glandular pustules, sometimes called pox, like chicken pox, smallpox, the bubonic plague have those big boils. So this is also part of a general immune response. So I hope that was helpful, and the next time I see you, we'll be talking about specific immune response. How does my body become specifically immune, let's say, to the chickenpox virus?